So let's get started. An important note: the negative hydrogen ion becomes the key determinant of opacity at the level of the photosphere. This is a surprising model since negative hydrogen ions are extremely unstable and observed on Earth only in particle accelerators and in the upper atmosphere.
Really? That's funny because I use reducing agents like sodium borohydride all the time when I worked in a chemistry lab. They deliver hydride ions to reduce carbonyls on a substrate. Reagents like this are cheap and common. But Pierre isn't pretending to be an organic chemist, so we can let this one slide.
No, this example does not show sodium borohydride producing free hydride ions, and it is completely irrelevant to the discussion. The fact that a compound has the word hydride in its name does not mean that it produces the free hydride ion. There are lots of hydrides in chemistry, so who cares? In sodium borohydride, the hydride is contained in a molecule involving sodium, boron, and hydrogen. It is not free. It is also never free when it is transferred to another molecule. An intermediary transition complex is created, and bonds are simultaneously breaking and forming during the process. The free unbound hydride is never present. Now, Dave stated in his video that the sun is a gaseous plasma and that it is too hot for atomic hydrogen to exist. Like the astronomers, he wants the electrons completely stripped from the atom. Yet the same astronomers are proposing that the photosphere of the sun contains lots of free hydride. They need it to explain the solar spectrum. But in the free hydride, the hydrogen nucleus not only binds one electron, but now has to try to hold on to two. That is central to the stellar opacity problem, as you can learn in these classic papers and as I have reviewed here. Now, does that make any sense? What do you want exactly? A fully ionized plasma or a photosphere with conditions enabling lots of free hydride to exist? Astronomers should really make up their mind because these two ideas are diametrically opposed. In any case, the free hydride ion is an extremely unstable species, exactly like what I said. But where could we learn more about the free hydride ion? How about this sentence in the Astrophysical Journal? Although the detection of hydride in astrophysical environments remains elusive, a firm acceptance of its presence exists. That is astrophysics in a single sentence. Absolutely no direct evidence required to enable a strong position. Let's move on. The sun is said to be unable to synthesize elements beyond the lightest, focusing only on the synthesis of helium. In this way, modern solar theory has crippled our sun because it can't make any of the heavy elements.
Nope. Stars the mass of our sun fuse helium nuclei together to produce carbon and oxygen through the triple alpha process, and heavier stars fuse all the way up to iron during their lifetime, then producing the heavier elements when they go supernova. We know this conclusively from spectral analysis. More Astronomy 101 information that is totally lost on Pierre.
No, Dave, you're advocating something which is completely false. The standard model of the sun focuses on the production of helium from hydrogen, exactly like what I said. I am correct. The astronomers have crippled our sun. They permit the pp reaction and the CNO cycle to produce helium, as described in this classic graduate text by Kip and Hom on stellar physics. Astronomers claim that the presence of heavier elements are just the remnant of some first-generation star that went supernova. These remnants were then pulled into the sun when it formed. The more simple and obvious explanation is that those elements are there because the sun synthesized them. Forget about the need for a first-generation star. Either way, the triple alpha reaction is never occurring in the sun according to modern theory. That is why you will never find it in a book such as this one, which focuses on the sun. It occurs only in stars with a core 10 times hotter than currently proposed for the core of the sun. Here's an Astronomy 101 book, and the triple alpha reaction is clearly in the section on evolved stars like red giants. I don't know who was asleep in Astronomy 101, but it was not me. Let's move on. Here is the spectrum of atomic hydrogen. Note that the gaseous hydrogen emits in narrow bands, whereas the solar spectrum from the photosphere is continuous. We will cover this in greater detail in a later video. For now, remember that in Secchian phase case, the white light of the sun could only be produced by condensed matter.
He is comparing the emission spectrum of molecular hydrogen gas to the sun's blackbody spectrum and complaining that if the sun is made of hydrogen, these should look the same. He does not understand that the sun is not molecular hydrogen. It's a plasma of primarily hydrogen and helium nuclei. It's not discrete hydrogen atoms with an electron that moves between energy levels, absorbing and emitting photons to produce the emission lines we are familiar with from observing molecular hydrogen gas in a canister here on Earth. He doesn't even seem to understand the Bohr model of the hydrogen atom, something which is learned by every high school chemistry student.
Sorry, but gases and plasmas in the lab never produce a smooth, continuous spectrum like the sun, as you are trying to claim. I have a PhD in chemistry and I understand the Bohr model of hydrogen. You are just making stuff up without properly describing what is happening to your audience. The reality is that a gaseous plasma is characterized by strong emission lines and bands. The sun has a continuous spectrum, and one will not be able to find a single example of an isolated plasma on Earth which emits like the sun. In experiments that have some continuous features, the plasma is always confined by condensed matter, often graphite like in tokamak reactors. Many people like to compare the blackbody spectrum of the sun to the emission of a sodium lamp. However, even a sodium lamp is not blackbody in appearance. Furthermore, unlike a sodium lamp, the photosphere in the standard solar model has a density of only 10 to the minus 7 grams per centimeter cubed. That is a lower density than some of the best vacuums produced in labs. You will never find a blackbody spectrum coming from such material. The fact is, I finished explaining the solar spectrum in both my model and the standard model a long time ago. My model is simple and elegant, while the standard model is much more complicated than Dave alludes to. It involves the solar opacity problem, and it invokes a wide range of processes, including not only atomic transitions, but also many other processes. Sky Scholar has videos explaining it, and it is discussed in detail in this paper. The claim that the sun produces a continuous spectrum because it is a hydrogen plasma is absurd, and even astronomers would disagree with such a simple statement. Take the time to learn about solar opacity tables, and you will discover the mess that is involved. I have stated that the spectrum of the sun must be produced by a single spectroscopic process, exactly identical to what happens in graphite. It must not be produced by the sum of processes completely unrelated to thermal emission on Earth, and which can never explain why you get a blackbody spectrum from graphite. Astrophysics cannot use one process in graphite and a completely different set of processes in the sun. Spectroscopy does not work that way. Those who believe otherwise expose their lack of understanding of this subject. I am correct. So time to move on to another topic. And reaches temperatures of 15 million Kelvin degrees.
Kelvin degrees? They're just called Kelvin, Pierre. Again, high school chemistry students know this.
This is such an unimpressive point of attack. I know the SI unit is just Kelvin, and in almost all other cases on Sky Scholar, that's how I say it. I am 60 years old. When I was a student, many books used degrees in referring to the Kelvin scale, despite the changes in 1967. So did all my older professors. For instance, in graduate school, I studied with this classic text, Advanced Physical Chemistry by Davis. It used degrees Kelvin even when they published a second edition in 1976. The SI convention acts as a reminder that the Kelvin scale is absolute. In fact, I discuss it here. Absolute zero is part of the Kelvin temperature scale. It corresponds to minus 273.14 degrees Celsius or minus 459.67 degrees Fahrenheit. To remind ourselves, the Kelvin scale sets zero as an absolute quantity. Degrees are not normally used when giving a value in Kelvin. So instead of saying 0 degrees Kelvin, we just say 0 Kelvin. Enough said. It's time to move on. Astronomers believe that the sun's surface is an optical illusion, and that the solar body is nothing but a big ball of gaseous plasma.
Saying gaseous plasma is like saying solid liquid. Gas and plasma are different phases. The sun is plasma.
In this case, it helps us to see why we view the sun today as a ball of gas, from the surface all the way down to the core.
Again, no, the sun is not gas, it's plasma. Gases are made of atoms and molecules that are intact. Plasmas are not. We do not view the sun as gas all the way down to the core because it's plasma. It's too hot in there for atoms to exist. Gas and plasma are not synonyms. He doesn't seem to even know what the phases of matter are.
Of course, in high school and in college, we learned that there are 4 states of matter: solids, liquids, gases, and plasma. But believe it or not, relative to plasmas, there are actually 3 types. Here is a quote from an advanced text on plasma physics. Plasma is an ionized state of matter in the solid, liquid, or gaseous form. But the last mentioned one is the most studied. Things do get more complicated in advanced coursework, and that should not surprise anyone. As an example, my model of the sun states that the photosphere is comprised of metallic hydrogen in a hexagonal planar lattice. That is known as a one-component plasma. The nuclei occupy a relatively fixed location, while the electrons are fully delocalized. That is why they are thought of as a plasma. I also refer to the sun as a gas when explaining the Standard Model, and so do the astronomers in advanced coursework. For instance, here is a quote from a classic book used in graduate solar physics classes. Unfortunately, convection in stars proceeds under rather malicious conditions. Turbulent motions transport enormous fluxes of energy in a very compressible gas, which is stratified in density, pressure, temperature, and gravity over many powers of 10. They are not speaking about a compressible plasma, so perhaps Dave should write to them to educate them about the phases of matter. Here is a quote explaining how the astronomers actually think. In the deep interior of stars, the gases are fully ionized, i.e. for each hydrogen nucleus, there also exists a free electron, while for each helium nucleus, there are 2 free electrons. We therefore have a mixture of 2 gases, that of the nuclei, which in itself consists of more than one component, and that of the free electrons. The mixture can be treated as a one-component gas if all single components obey the ideal gas law. Here is another quote from a graduate text. While hydrogen is converted into helium by either the pp or CNO cycle, the mean molecular weight mu of the gas increases. If neither the temperature nor the density of the gas changes, the ideal gas law predicts that the central temperature will necessarily decrease. So you see, astronomers themselves always refer to stars as gases. You will find thousands of such quotes in advanced astronomy books. This is because their models are based on the ideal gas law, and that law refers to gases, hence the name. Enough said. Let's move on. Unfortunately, in the gaseous model of the sun, there are no real surfaces by which pressure can even be defined. There is no area in the force over area definition of pressure.
He is implying there is no pressure without a surface. This means he doesn't know what pressure is. Atmospheric pressure exists and has some value no matter where you are in the atmosphere. You don't have to scoop some of it up and put it in a container in order for it to exert pressure. The same goes for liquids. There are no physical barriers separating different ocean depths, but the pressure becomes greater as you go down. And the same goes for plasma. The more massive the star, the greater the gravitational compression pushing inwards. It's not that hard to understand.
If the sun truly has a fully gaseous interior, there are 2 problems. First, how do astronomers prevent the sun from collapsing on itself? Secondly, how does a gaseous sun maintain a stable radius? Remember that the rule in the laboratory is that a gas expands to fill the void, yet the sun is stable. So how is that achieved if the sun is truly a gas?
Again, it's not gas, it's plasma. Stellar material doesn't expand to fill all of space because gravity exists, and stars don't collapse because of all the energy being released from the fusion reactions happening in the core. Gravity pulls the matter in, fusion reactions push the matter out. It's called hydrostatic equilibrium. Ever heard of it?
Astronomers argue that within each star, the inward directed force of gravity is counterbalanced by an externally directed gas pressure and radiation pressure. When all these forces balance, we have hydrostatic equilibrium.
There you go, buddy. All good now?
But for now, what is gas pressure? First, think about the atmosphere above the Earth. Gas pressure supports our atmosphere. As you remember from earlier, pressure is equal to force over area. Gas pressure is generated when an atom in our atmosphere strikes the surface of our planet. At that point, much like a billiard ball, it bounces off the surface and is redirected upward. The net result is that any movement of an atom downward is immediately transformed upward. You will note that in order to generate atmospheric gas pressure, we needed a true surface.
This is getting embarrassing, even for Pierre. He is saying that atmospheric pressure only exists at the surface of the Earth when gas particles strike the ground, and that by extension, there can be no pressure inside a star because there is no solid surface inside a star. We now have to downgrade Pierre's comprehension of basic scientific terminology from failing high school to failing middle school. In Pierre's world, our lungs couldn't function even 5 feet above the ground. Fortunately, in reality, the atmosphere exerts a gradient of pressure from the ground all the way up to space. We can climb mountains and go hang gliding without worrying about suffocating. The same applies inside the sun. When we talk about pressure as being some force applied over an area, it's just any hypothetical area. It doesn't have to be a literal solid surface. We can construct a shell of any radius and do the math. Sorry, Pierre, back to 7th grade.
Okay, let's go over this. I never stated that the pressure exists only at the surface. I stated correctly that it was generated at the surface. The effect is then transferred throughout the system. The ideal gas law in chemistry was discovered using real containers, not imaginary boundaries. That is something you'd learn when studying the kinetic theory of gases in third-year physical chemistry courses or in graduate school. Here's an easy online tutorial for everyone to learn that the generation of pressure in an ideal gas is all about the momentum change at the wall of the container, and this is taught by a physics professor. The tutorial properly neglects the force of gravity, as gravity is not part of kinetic theory. Gas particles only have a net change in momentum at the surface of the container, and that is where pressure arises. That is why pressure is equal to force over area. Now think about this equation for a moment. Force is equal to mass times acceleration, and acceleration is equal to a change in velocity over a change in time. You can't get a change in velocity using an imaginary surface. If we were to imagine a gas and an imaginary surface, we can also imagine the fact that there would not be a net change in momentum at that surface. Why? Because it's imaginary, just like the tooth fairy or unicorns. Imaginary surfaces are used in physics, but only in assessing things like flux, not something like pressure. Dave also does not properly understand the difference between simple and complex systems. The gaseous stars are simple systems with one state of matter. They have no surfaces and therefore can never generate the electron gas pressure that the standard model requires. In contrast, the atmosphere of the Earth is complex, with both a gaseous atmosphere and the surface of the Earth itself. The latter, as a ball of condensed matter, exerts a gravitational force on the gas. A net change in momentum occurs when the gaseous atoms strike the surface of the Earth, producing gas pressure in the atmosphere. Any pressure measuring device and your lungs also have a surface. A plane's wing experiences lift due to a differential pressure against a real surface. Perhaps Dave can try to be the first person to fly using an imaginary wing. He is talking nonsense. The problem is not that I have not passed middle school, but rather that the astronomers and the people who repeat their claims either never properly understood or properly applied kinetic theory. Let's move to another topic. Imagine a container of pressurized gas in a locker under vacuum. If you opened it, the gas would fill the locker evenly. Then if you opened the locker in a room under vacuum, the gas would spread out evenly to fill the whole room, and so on and so forth. Now imagine starting with a lot of gas in an enormous room and releasing it into an infinite vacuum universe. What would you expect to happen? If you are a rational thinker, you might expect the gas to expand to fill the void, just like it does when it was released into an empty room. If you were an astronomer, you would say that the gas acts differently and instead of spreading out, shrinks down to form a star. In the standard solar model, this is called gravitational collapse, which can be extended to include black holes and the theoretical aspects of the Big Bang. Astronomers believe that stars are created by the gravitational collapse of a gaseous mass. This was once known as Laplace's nebular hypothesis, but today is known as a solar nebular disk model. This idea stands against the known observation that gases expand to fill the void. So how does astronomy get into this mess?
It's not getting any better here. Pierre thinks that a tiny sample of gas in a container and a gas cloud of many solar masses will behave the same way. Sorry, they don't. The gravitational attraction between some gas particles in a tiny container is not only negligible in general, but also beyond negligible compared to the gravitational pull of the Earth that the container is near. A cloud of many solar masses in deep space is not the same. The gravity between the particles is the only force acting upon them, and it's a lot of gravity because it's a lot of mass. This idiotic analogy he puts forward is the equivalent of flat earthers asking to see water stick to a spinning ball. Well, a tennis ball doesn't generate the gravitational field that the Earth does, and some gas in a box doesn't generate the gravitational field that a gas cloud of many solar masses does. Some people have criticized me for comparing cranks like Pierre to flat earthers, but the more I do these debunks, the more I see how similar they are.
Dave insists that our knowledge of gaseous properties on Earth do not extend to stars or large gaseous masses in space. This is such a strange argument. Is there any meaning whatsoever to observations shown time and time again in our laboratories? After all, that is how the laws of physics are determined. I have emphasized that gases expand to fill empty space in every scenario. Like the astronomers, however, Dave argues that the effect of gravity brings about gravitational collapse. However, he has failed to address the thermodynamic consequences of gravitational collapse in a gas. I have already addressed the point in detail in these videos. On Earth, gases and plasmas possess what is known as positive heat capacity. The more gas or plasma one has, the more heat the total material can handle. If you can add heat to a gas, its temperature goes up, not down. However, the gaseous stars of modern astronomers invoke negative heat capacities as a result of gravitational collapse. So as the star radiates and loses heat, its temperature actually goes up. A Nobel Prize was awarded to Chandrasekhar for solving this mathematical mess, but in fact Chandrasekhar simply added a band-aid to a mortal wound. Just consider this question for a moment. How massive does a gas have to become in order for its heat capacity to change from positive to negative? Astronomers can never answer the question, and this highlights the absurdity of the gaseous models. Either way, the gravitational collapse of a gas is a violation of the laws of thermodynamics. Stars have long been considered closed systems, and such a system cannot do work upon itself, raise its own temperature, and decrease its own entropy. That is a violation of the first and second laws of thermodynamics. Furthermore, the temperature of gaseous stars is not intensive as required by the zeroth law. This causes Eddington's mass-luminosity relationship to violate laws of thermodynamics, as I explained in detail in this paper. Thermodynamics is warning astronomers that they cannot gravitationally collapse a gas because when they do so, they produce violations of known thermodynamics. The heat capacity of a gas is positive, and the astronomers cannot argue otherwise. Let's move to another topic. Dave returns to the emission spectrum of the sun from here, but there is no new information. Suffice it to say that Dave does not understand the subject despite his claims. I have already produced many papers and videos on Kirchhoff's law, blackbody radiation, and the generation of the solar spectrum, which are linked below. It takes a vibrational lattice to produce a thermal spectrum, as I published long ago in this paper. Astronomers argue that no, it only takes thermal equilibrium, thanks to Kirchhoff's law of thermal emission. But they rested their argument on a crumbling foundation. In fact, the presence of resonant cavities everywhere on Earth demonstrates that Kirchhoff's law is false. Dave and the astronomers would be well served to learn about the history of Kirchhoff's law of thermal emission. It was generated solely from mathematics, with no experimental proof to this day. What is worse is that not even a single mathematical proof of Kirchhoff's law has survived. As such, the law is now based on nothing, neither theory nor experiment. Many physicists also confuse Kirchhoff's law with Stewart's. The equivalence of emission and absorption under thermal equilibrium condition is not a proper statement of Kirchhoff's law. That is Stewart's law. In any case, Dave will be quick to state that no one is listening to what Dr. Robitaille is talking about relative to Kirchhoff's law. In fact, he is wrong. Here is a list of all the times my work on Kirchhoff's law has been cited so far, and some of the citations are in notable journals, even the best journals in physics. Some people are beginning to understand that Kirchhoff's law of thermal emission is not correct, and that is a death blow to modern astrophysics. The radiation inside opaque cavities at thermal equilibrium is not always black. For example, here is a quote from a group of physicists in Prague which cite my work. Reference 21 is my paper. Note that these authors recognize that the idea that blackbody radiation is contained in all opaque containers is an illusion. Kirchhoff's law is false, as my paper which they cite explains. There is something important here which Dave is missing. The fact that Kirchhoff's law of thermal emission is not correct has consequences, namely that modern astrophysics will eventually collapse. In that regard, astrophysics is not the same as observational astronomy. Dave cannot argue that I am unqualified to discuss the subject. Kirchhoff's law of thermal emission is part of spectroscopy, and as a spectroscopist, I do have the training to question its validity. It is not just a question of astrophysics. In any case, if Kirchhoff's law was correct, then it would be trivial to make black bodies in the laboratory, as everything would be independent of the nature of the walls. However, the construction of proper black bodies is not a trivial process, as everyone who has ever worked with one at the National Institutes of Standards and Technology recognized. It's time to move to another topic.